Okay, last meeting, no, our presenter discussed about the exploratory data analysis or the EDA. No? So, wait. Okay, so to continue our discussion. So last time we discussed about the exploratory data analysis or EDA. So EDA is a method of analyzing and comprehending data that focuses on visualizing and summarizing patterns and relationship in the data rather than making any assumptions about the underlying statistical distributions. Because the goal of EDA is to gain insights and develop an understanding of the data. So as well as to identify potential outliers, errors, and missing values that may need to be addressed before conducting from any formal statistical analysis. So EDA or exploratory data analysis consists of different steps. No, number one, data gathering and cleaning. So the first step in EDA is to collect and clean the data, eliminating any obvious errors or inconsistencies. Number two, data visualization. So to visualize data and understand its distribution, spread, and correlations, various graphical techniques such as histogram, box plots, scatter plots, and heat maps are used. So data transformation, of course, and scaling. So to facilitate visualization and analysis, that data can be transformed or scaled as needed. And of course, descriptive statistics to summarize the data basic statistical measures such as mean, median, mode, standard deviation, and correlation coefficients actually are calculated. We consider the pattern recognition because the data is examined for any possible patterns or trends. Detection of outliers, of course. Outliers are data points that differ significantly from the other observations and may have an undue influence of the undue on the analysis. No, EDA can consist in identifying these outliers. And of course, hypothesis generation. Hypotheses about the data and underlying populations can be generated based on the insights gained from EDA. Because EDA is a critical step in the data analysis process because it can assist in identifying potential issues in the data and guiding the selection of appropriate statistical techniques for further analysis. No, it is flexible and iterative process that allows the exploration and discovery of insights that would be missed, no, by a more formal analysis. So data visualization technique refers to a variety of tools and methods for visually representing and displaying data. So by representing complex data sets in the way that allows for easy and intuitive interpretation, data visualization aims to make complex data sets more accessible, understandable, and actionable. Among the most common data visualization techniques are line chart. No? So our presenter give us examples about line charts because line charts are used to show data trends over time and are especially useful for visualizing changes in variable over time. Another is the bar graphs. No, bar graphs are used to compare data across categories or groups. They are especially useful for displaying non-continuous discrete data. No, scatter plots are used to demonstrate, of course. Another is the scatter plots. Scatter plots are used to demonstrate the relationship between two variables. On the graph, no, each data point is plotted with one variable on the x-axis and the other variable on the y-axis. No? We have, of course, the heat maps. No? Heat maps are used to visualize data patterns by using color to represent the intensity of a value. They are essentially useful for displaying large amount of data as well as identifying trends and clusters. No? Another is the tree maps. No? Tree maps are used to visualize hierarchical data structure. So each level of the hierarchy is represented by the rectangle, whose size is proportional to the data values at the level. Geographic maps are very much useful right now because geographic maps are used to visualize data that is related to specific geographic locations, like different applications available right now in the market, like Zoom, not Zoom, Grab, they were using Waze, actually Waze and Google Map, and so on. They are especially helpful in displaying special patterns and trends. Imagine that they could be able to identify which on which the easiest, or the not easiest, but that is what we call the coordinate statistics hour in project management, or system management design, getting the critical path method, the CPM. We could identify which is the shortest path, the shortest path. And therefore, they are especially helpful in displaying special patterns and trends. Word clouds right now. Word clouds are used to visualize, represent text data by displaying the most frequent occurring words. And number 8, of course, is the infographics. An infographics is a visual representation of complex information that combines text, images, and data visualization. Actually, these are just a few of the numerous data visualization technique available, because the technique used will determine by the type of data being visualized, the message being conveyed, and the audience of whom the visualization is intended. So, what exactly is summary statistics? Our presenter last time discussed that summary statistics are numerical measures that describe the main characteristic of a set of data. They are used to summarize data distribution and approve a quick and simple way to understand and compare data sets. Some of the most common summary techniques are central tendency measures, or measure of central tendency, dispersion measure, range, variance, standard deviation. This will be used to describe the spread of data. They have also percentiles, describe the positions of a specific value in the data set in relation to their other values. We have skewness and kurtosis. Skewness is measured to data's asymmetry, whereas kurtosis is measured of data thickness. I think you already discussed and simulate or compute this type of numerical measures during your quantitative methods, because it covers the summary statistics. So you are learned previously on how you'll be able to compute the mean, median, mode, of course, to describe the data set centers. You know how to identify the range, get the variance and standard deviation to describe the spread of the data, and of course the percentile, let's say 75th percentile, of course, of the data falls. And you have also know how to measure a data asymmetry for kurtosis, and skewness for skewness and others. Again, as I mentioned, skewness is a measure of data asymmetry, whereas kurtosis is a measure of data thickness. So then, of course, it is important for us to understand and how we'll be able to get the correlation coefficients. What I'm talking about right now is the research aspect of, or the research aspect of this data or quantitative methods that we have here right now. Because as a practitioners, we need to understand some techniques and tools, or must be identified, especially by crafting your capstone project or developing your system, which required to your capstone project. So, correlation coefficient, these are used to describe the relationship between two variables. Most commonly in some research, especially if they were not IT, for business, allied health, they have a statement of the problem, wherein during the statement of the problem, they need to identify the significant relationship, no, significant differences of two variables. Na, so when we say correlation coefficient, this will be identifying significant relationships. Now, person correlations, no, coefficient is the most commonly used for correlation coefficient. No? So for correlation coefficient, we are using person R, okay, or person correlation coefficient. No? Summary statistics are used in variety of fields such as IT, business, economics, psychology, and social sciences. They make it simple to understand and compare data sets, and they can help identify potential outliers or anomalies in the data. It should be noted, however, that summary statistics only provide complexities of the data sets. No? So how about the outlier detection? So actually, it's too easy to identify the outliers now. The process of identifying data points that differ significantly from the other observation in the dataset is known as outlier detection, because outlier can be the result of a measurement of data entry errors, or they can be genuine but unusual observations. Outliers must be identified and handled carefully in many applications, including finance, healthcare, and social science, because they can have a significant impact on the result of a statistical analysis. So outlier detection methods include statistical methods, no? Statistical methods entail computing summary and statistics such as mean, median, standard deviation, and correlation coefficient, and then identifying observations that fall outside of the specific range of distribution or a range or distribution. We have also visualization techniques, no? Visualization techniques involve the creation of graphs or plots to visually inspect the data for unusual observation. Box plots, scatter plots, and histogram are an example of visualization techniques. As an IT practitioner, of course, we have machine learning methods, no, algorithms. No, algorithms are used in machine learning methods to identify patterns and anomalies in the data. So clustering algorithms, for example, can be used to group similar observations together. And any observations that do not fit into any of the cluster may be considered as outliers. Now, we have, of course, the domain-specific methods. No? Domain-specific knowledge may be used to identify outliers in some cases. In healthcare, for example, certain vital sign values such as blood pressure or heart rate may be flagged as outlier if they fall outside of clinically acceptable ranges. So imagine, let's say, for example, your heart rate, let's say, is, or your blood pressure is 180 over 100, or kaya 200 over 90, something like that. No? So that is domain-specific methods. No? It is important to note that outlier detection is not a one-size-fits-all approach. No? In the method used will be determined by the data's characteristics and the application. Outliers may need to be removed or treated before further analysis. Or they may contain valuable information that should be pursued. I just want to show you a video presentations now of data or exploratory data analysis applying no in the research, no, because I think right now you are you have an ongoing capstone project, no, development. So I will be able to use these discussions in our capstone project, which is actually very important. No, it's very challenging to an IT practitioner, no, to develop your own system. Okay, so.
Hi, my name's Will, and I'm going to give you a step-by-step guide to the data analysis process. Let's go.
An overview and an introduction to each of these stages, as well as looking at some of the tools you'll use to undertake these stages. So let's dive into step 1, defining the question. The first step in your data analysis process or any data analysis process is to define your objective. In data analytics terms, this is called the problem statement. Defining your objective means coming up with a hypothesis and figuring out how exactly to test it. You can start by asking, what business problem am I trying to solve? Now, I know this might sound straightforward, but it can actually be trickier than it seems. For instance, your organization's senior management might pose a question such as, why are we losing customers? It's possible though that this doesn't get to the core of the problem. A data analyst's job is to understand the business and the business's goals. As a data analyst, you need to understand this in enough depth that they can frame the problem the right way. To give you a practical example, let's say you work for a fictional company. For example, we'll call it Top Notch Learning. This fictional company, Top Notch, creates custom training software for its clients. In this example, Top Notch is excellent at securing new clients. But unfortunately, Top Notch has much lower repeat business. As such, as a data analyst, your question might not be why are we losing customers, but which factors are negatively impacting the customer experience? Or even better yet, how can we boost customer retention whilst minimizing costs? Now you've identified the problem, you need to find which data is going to help you solve this issue. This is where your business acronym comes in again. For instance, perhaps you've noticed that the sales pipeline for new customers is very slick, but the production team is extremely inefficient. Knowing this, you could hypothesize that the sales process actually wins a lot of new clients. But the customer experience, well, it's kind of lacking. Could this be the reason that customers aren't coming back? What sources of data will help you answer this question? As a data analyst, considering all these things will help you define the question and help you solve the problem at hand. There's also a number of tools that can help you define your objective. Defining your objective is mostly about soft skills, so business knowledge and lateral thinking. But you'll also need to consider business metrics and key performance indicators, and these are called KPIs. Monthly reports can help you track problem points in the business. There are lots of tools out there on the market that can analyze this business data. Tools like Databox and Dasheroo. There's also free open source software like Grafana, Freeboard, and Dash Builder. These are fantastic for producing simple dashboards, both at the beginning and at the end of the data analysis process. So that was step 1, defining the objective. On to step 2. Step 2, collecting the data. Once you've established your objective, you'll need to create a strategy for collecting and aggregating the appropriate data. A key part of this is determining which data you need. This might be quantitative data or numeric data, e.g. sales figures or monthly reports, or qualitative, descriptive data, such as customer reviews. All of this data fits into one of 3 categories: first party, second party, and third party data. Let's explore each one briefly now. What is first party data? First party data is data that you or your company has directly collected from customers. It might, for example, come in the form of transactional tracking data or information from your customer relationship management system, your CRM system. Whatever its source, first party data is usually collected in a clear and structured way. Other sources of first party data might include customer satisfaction surveys, focus groups, interviews, or direct observation. Let's talk about second-party data. To enrich your analysis, you might want to secure a secondary data source. Second-party data is simply the first-party data of other organizations. This might be available directly from the company or from a private marketplace. The main benefit of second-party data is that it's usually structured, and although it's less relevant than first-party data, it tends to be reliable. Examples of second-party data include website, app, or social media activity, like online purchase history or shipping data. So lastly, what is third-party data? Third-party data is data that has been collected and aggregated from numerous sources from a third party. Often, but not always, third-party data contains a lot of unstructured data or big data. Many organizations collect this big data to create industry reports or to conduct market research. The research and advisory firm Gartner is a good real-world example of an organization that collects big data and then sells it on to other companies. Open data repositories and government portals are also sources of third-party data. Let's take a moment to look at some of the tools that you can use to collect data. Once you've devised a data strategy, i.e. you've identified what data you need and how best to go about collecting it, there are many tools that you can use to help you. One thing you'll need, regardless of industry or area of expertise, is a data management platform, or DMP. A DMP is a piece of software which allows you to identify and aggregate data from numerous sources before then manipulating them, segmenting them, and so on. There are many DMPs available. Some well-known enterprise DMPs include Salesforce DMP, SAS, and the data integration platform Exploratory. If you want to play around, you can also try some open source platforms like PIMCore or DSwarm. On to step 3, cleaning the data. Once you've collected your data, the next step is to get it ready for analysis. This means cleaning or scrubbing it, and this is crucial to make sure that you're working with high quality data. Key data cleaning tasks include removing major errors, duplicates or outliers, all of which are problems when you aggregate data from numerous sources. Removing unwanted data points, so extracting irrelevant observations that have no bearing on your intended analysis. Bringing structure to your data or general housekeeping, so for example fixing typos or layout issues, which will help you map or manipulate your data more easily. And finally, it helps filling in major gaps. As you're tidying up, you might notice that important data is missing. Once you've identified these gaps, you can go about filling them. A good data analyst will spend about 70% to 90% of their time cleaning data. This might sound excessive, but focusing on the wrong data or analyzing erroneous data will severely impact your results. It might even send you back to square one. So whatever you do, don't rush this step. Let's have a look at some of the tools that you can use to clean your data. Cleaning data manually, especially large data sets, can be incredibly daunting. But luckily, there are many tools available to streamline this process. Open source tools such as OpenRefine are excellent for basic data cleaning, as well as high-level exploration. However, free tools offer limited functionality for very large data sets. Now, I know this sounds like a data zoo, but Python libraries such as Pandas and some R packages are better suited to heavy data scrubbing. You will, of course, need to be savvy with the languages. Alternatively, enterprise tools are also available. For example, Data Ladder, which is one of the highest rated data matching tools in the industry. There are many more. Why don't you see which data cleaning tools you can find online? Share your free tools in the comments below. So that was step 3, cleaning the data. On to step 4, analyzing that data. Finally, once you've cleaned your data, now comes the fun bit, analyzing it. The type of data analysis you conduct largely depends on what your goal is, but there are many techniques available. Univariate or bivariate analysis, time series analysis, and regression analysis are just a few you might have heard of. More important than the different types, though, is how you apply them. This depends on what types of insights you're hoping to gain. Broadly speaking, all types of data analysis fit into the 4 following categories. Descriptive analysis, which is analysis which identifies what has already happened. This is a common first step that companies do before proceeding with deeper explorations. Diagnostic analysis, where the focus is on understanding why something has happened. It is literally the diagnosis of a problem, just as a doctor uses the symptoms to diagnose the patient's disease. Predictive analysis, which is where you identify future trends by the analysis of historical data. Predictive analysis is commonly used by businesses to forecast future growth. And lastly, prescriptive analysis, which allows you to make recommendations for the future. This is the final step in the analytics part of the process, but it's also the most complex. This is because it incorporates aspects of all the other analyses that we've described today. Step 5, sharing your results. You've finished carrying out your analyses, you have your insights. The final step of the data analysis process is to share these insights with the wider world, or at least with your organization's stakeholders. This is actually more complex than just sharing the raw results of your work. It involves interpreting the outcomes and presenting them in a manner which is digestible to everybody that's in the room. Since you'll also present your work to decision makers, it's very important that the insights that you share are 100% clear and also unambiguous. For this reason, data analysts usually use reports, dashboards, and interactive visualizations to support their findings. How you interpret and present results will often influence the direction of the business. Depending on what you share, your organization might decide to restructure, to launch a new product, or close an entire division. That's why it's very important to present all the evidence that you gathered and not to cherry-pick data. Ensuring that you cover everything in a clear and concise way will prove that your conclusions are scientifically sound and based on facts. On the flip side, it's important to highlight any gaps in the data or to flag any insights that might be open to interpretation. Remember that honest communication is an important part of the process. It will help the business, but it will also help you to excel at your job. There's a ton of tools for interpreting and sharing your findings. These tools are suited to different experience levels, but popular tools that require no coding skills include Google Charts, Tableau, Data Wrapper, and Infogram. If you're familiar with Python and R, there are also many data visualization libraries and packages available. For instance, check out the Python libraries Plotty, Seaborn,
Again, this data visualization is a critical aspect of big data analytics that enable us to represent data graphically and communicate insights effectively. So it involves creating visual representation of data and informations. No? And if you're beginner in data analysis, no, or data visualization, there are certain steps or guide to get you started. Number one, you need to identify the purpose of your visualization. Before creating a visualization, determine the goal of your analysis and what you want to communicate to your audience. No? Number two, choose the right type of chart or graph. No? Select a chart or graph that best represent your data and communicate your message effectively. Some common types of charts include bar chart, line chart, scatter plots, and pie chart. No? Number three, clean and prepare your data. Make sure your data is clean, accurate, in the right format for visualization. No? Number four, use colors and labels effectively. No, use colors and labels to highlight important data points and make your visualization more engaging. No, simplify your design. So necessary for you to a very napakabigat na siya, no, ng design. No, keep your design simple and avoid cluttering your visualization with too much information. No, test and refine your visualization. No, test your visualization with different audiences and make adjustment based on feedback. And number seven, use visualization tools. No? There are many data visualization tools available such as Tableau, Power BI. No? I think we have Power BI last time, no? And Google Data Studio that can help you create professional looking visualization. By following the sage step, no, you can create effective data visualization that help you understand your data and communicate insights in the audience. Okay.
Let's now start this lesson by defining what data visualization is. Data visualization is the technique to present the data in a pictorial or graphical format. It enables stakeholders and decision makers to analyze data visually. The data in graphical format allows them to identify new trends and patterns easily. Well, you might think, why data visualization is important? Let's explain with an example. You are a sales manager in a leading global organization. The organization plans to study the sales details of each product across all regions and countries. This is to identify the product which has the highest sales in a particular region and up the production. This research will enable the organization to increase the manufacturing of that product in the particular region. The data involved for this research might be huge and complex. The research on this large numeric data is difficult and time-consuming when it is performed manually. When this numeric data is plotted on a graph or converted to charts, it's easy to identify the patterns and predict the result accurately. The main benefits of data visualization are as follows. It simplifies the complex quantitative information. It helps analyze and explore big data easily. It identifies the areas that need attention or improvement. It identifies the relationship between data points and variables. It explores new patterns and reveals hidden patterns in the data. There are three major considerations for data visualization. They are clarity, accuracy, and efficiency. First, ensure the data set is complete and relevant. This enables the data scientist to use the new patterns yield from the data in the relevant places. Second, ensure using appropriate graphical representation to convey the right message. Third, use efficient visualization technique, which highlights all the data points. There are some basic factors that one would need to be aware of before visualizing the data. Visual effect, coordination system, data types and scale, informative interpretation. Visual effect includes the usage of appropriate shapes, colors, and size to represent the analyzed data. The coordinate system helps to organize the data points within the provided coordinates. The data types and scale choose the type of data, such as numeric or categorical. The informative interpretation helps create visuals in an effective and easily interpretable manner using labels, title, legends, and pointers. So far, you have learned what data visualization is and how it helps interpret results with large and complex data. With the help of the Python programming language, you can perform this data visualization. You'll learn more about how to visualize data using the Python programming language in the subsequent screens. Many new Python data visualization libraries are introduced recently, such as Matplot Library, Vispi, Bokeh, Seaborn, Pygel, Folium, and Networks. The Matplot library has emerged as the main data visualization library. Let's now learn about this Matplot library in detail. Matplot library is a Python two-dimensional plotting library for data visualization and creating interactive graphics or plots. Using Python's Matplot library, the data visualization of large and complex data becomes easy. There are several advantages of using Matplot library to visualize data. They are as follows. It's a multi-platform data visualization tool built on the NumPy and SciPy framework. Therefore, it's fast and efficient. It possesses the ability to work well with many operating systems and graphic backends. It possesses high-quality graphics and plots to print and view for a range of graphs, such as histograms, bar charts, pie charts, scatter plots, and heat maps. With Jupyter Notebook integration, the developers have been freed to spend their time implementing features rather than struggling with cross-platform compatibility. It has large community support and cross-platform support as it is an open-source tool. It has full control over graph or plot styles, such as line properties, fonts, and axis properties. Let's now try to understand a plot. A plot is a graphical representation of data, which shows relationship between two variables or the distribution of data. Look at the example shown on the screen. This is a two-dimensional line plot of the random numbers on the y-axis and the range on the x-axis. The background of the plot is called grid. The text first plot denotes the title of the plot, and text line 1 denotes the legend. You can create a plot using 4 simple steps. Import the required libraries, define or import the required dataset, set the plot parameters, display the created plot. Let's consider the same example plot used earlier. Follow the steps below to obtain this plot. The first step is to import the required libraries. Here we have imported NumPy and PyPlot and style from Matplot library. NumPy is used to generate the random numbers, and PyPlot, which is built in Python library, is used to plot numbers, and style class is used for setting the grid style. Matplot library inline is required to display the plot within Jupyter Notebook. The second step is to define or import the required dataset. Here we have defined the dataset random number using NumPy random method. Note that the range is 10. We have used the print method to view the created random numbers. The third step is to set the plot parameters. In this step, we set the style of the plot, labels of the coordinates, title of the plot, the legend, and the line width. In this example, we have used ggplot as the plot style. The plot method is used to plot the graph against the random numbers. In the plot method, the word G denotes the plot line color as green. Label denotes the legend label, and it's named as line 1. Also, the line width is set to 2. Note that we have labeled the x-axis as range and the y-axis as labels, and set the title as first plot. The last step is to display the created plot. Use the legend method to plot the graph based on the set conditions and the show method to display the created plot. Let's now learn how to create a two-dimensional plot. Consider the following example. A Nutri worldwide firm wants to know how many people visit its website at a particular time. This analysis helps it control and monitor the website traffic. This example involves two variables, namely users and time. Therefore, this is a two-dimensional or 2D plot. Take a look at the program that creates a 2D plot. Object Web Customers is a list on the number of users, and time hours indicates the time. From this, we understand that there are 123 customers on the website at 7 a.m., 645 customers on the website at 8 a.m., and so on. The ggplot is used to set the grid style, and the plot method is used to plot the website customers against time. Don't forget to matplot library in line to display or view the plot on the Jupyter Notebook. The website traffic curve is plotted and the graph is shown on the screen. It's also possible to change the line style of the plot. To change the line style of the plot, use define the line style as dashed in the plot method. Observe the output graph changes to a dashed line. Also note that the color is defined as blue. Using matplot library, it's also possible to set the desired axis to interpret the required result. Use the axis method to set the axis. In this example shown on the screen, the x-axis is set to range from 6.5 to 17.5, and the y-axis is set to range from 50 to 2000. Let's now understand how to set the transparency level of the line and to annotate a plot. Alpha is an attribute which controls the transparency of the line. Lower the alpha value, more transparent the line. Here, the alpha value is defined as 0.4. The annotate method is used to annotate the graph. The syntax for annotate method is shown on the screen. The keyword max is the attribute that denotes the annotation text. HA indicates the horizontal alignment. VA indicates the vertical alignment. XY text indicates the text position, and XY indicates the arrow position. The keyword arrow props indicates the properties of the arrow. In this example, the arrow property is defined as the green color. The output graph is shown on the screen. So far, you've learned how to set line width, title, x-axis and y-axis label, title of the plot, legend, line color, and annotate the graph for a single plot. The plot we created for website traffic in the previous screens is for only 1 day. Let's now learn how to create multiple plots, say for 3 days, using the same example. The dataset number of user for Monday, Tuesday, and Wednesday is defined with respect to its time distribution. Use different color and line width for each day to distinguish the plot. In this example, we have used red for Monday, green for Tuesday, and blue for Wednesday. The output graph is shown on the screen. A subplot is used to display multiple plots in the same window. With a subplot, you can arrange plots in a regular grid. All you need to do is specify the number of rows, columns, and plot. The syntax for a subplot is shown on the screen. It divides the current window into an M by N grid and creates an axis for a subplot in the position specified by P. For example, subplot 2, 1, 2 creates two subplots, which are stacked vertically on a grid. If you want to plot 4 graphs in one window, then the syntax used should be subplot 2, 1, 4. Layout and spacing adjustment are two important factors to be considered while creating subplots. Use PLT subplots adjust method with the parameters hspace and wspace to adjust the distances between the subplot and move them around on the grid. In this demo, you can see how to create two subplots that will display side by side in a single frame. Two subplots stacked one on top of the other or vertically split in a single frame, and 4 subplots displayed in a single frame. First, import matplotlib pyplot and style. Type %matplotlib in line to view the plot in Jupyter Notebook. Define the parameters such as temperature, wind, humidity, precipitation data, and time data. You can see the data being typed here. Next, to create two subplots to be displayed side by side in a given frame for 1, 2, 1 and 1, 2, 2, specify the figure size, subplot space, title, the color for time and temperature data, which is blue here, and line style and width. Similarly, specify the color for wind, which is red, its line style, and width. You can see the temperature and wind subplot charts displayed side by side in a given frame here. To create subplots for 2, 1, 1 and 2, 1, 2, specify the parameters. This will create two subplots stacked one on top of the other or vertically split in a given frame. Let's use humidity and precipitation data to plot the graphs. Specify the title, color, line style, and line width for both the graphs. You can see the two subplots stacked one on top of the other with two different colors indicating precipitation and humidity. Here, the two graphs are separate. Finally, let's draw four subplots for 2, 2, 1, 2, 2, 2, 2, 2, 3, and 2, 2, 4 that will display in a given frame. Specify the title, subplot data, color, line style, and line width for all four subplots. You can see the 4 subplots displayed in a single frame. In this demo, you learned how to create subplots displayed side by side, vertically split subplots, and 4 subplots displayed in a single frame using Matplotlib. You can create different types of plots using Matplot library: histogram, scatterplot, heat map, pie chart, error bar. Histograms. Histograms are graphical representations of a probability distribution. In fact, a histogram is a kind of bar chart. Using Matplot library and its bar chart function, you can create histogram charts. A histogram chart has several advantages. Some of them are as follows. It displays the number of values within a specified interval. It's suitable for large data sets as they can be grouped within the intervals. Scatterplots. A scatterplot is used to graphically display the relationship between variables. A basic plot can be created using the plot method. However, if you need more control of a plot, it's recommended that you use the scatter method provided by Matplot library. It has several advantages. It shows the correlation between variables. It's suitable for large datasets. It's easy to find clusters. It's possible to represent each piece of data as a point on the plot. In this demo, you'll learn how to generate a histogram and scatterplot using Matplotlib. Let's import a dataset called Boston Dataset, which we will use to create the histogram and scatterplot from the scikit-learn library. Let's import Matplotlib pyplot. Type %matplotlib in line to view the plot in Jupyter Notebook. Let's use the data in Boston Real Estate Dataset to create the histogram and scatterplot. Load this data. You can view this data by using the print command. Now define the x-axis for the data, which is Boston Real Estate Data. Likewise, define the y-axis for the data, which is Boston Real Estate Data, with the target extension. Specify the plot style, figure style, number of bins, and labels of the x-axis and y-axis. Use the show method to display the histogram created by you. Specify the style, size, datasets, and labels of the scatter plot that you want to create. Use the show method to display the scatter plot created by you. Heat maps. A heat map is a better way to visualize two-dimensional data. Using heat maps, you can gain deeper and quicker insight into data than those afforded by other types of plots. It has several advantages. It draws attention to the risky-prone area. It uses the entire dataset to draw bigger and more meaningful insights. It's used for cluster analysis and can deal with large datasets. In this demonstration, you'll learn how to generate a heat map for a dataset using matplotlib. Let's import the required libraries: matplotlib, pyplot, and seaborn. Type %matplotlib inline to view the plot in Jupyter Notebook. Let's load the flights dataset from the built-in datasets of Seaborn library. Use head to view the top 5 records of the dataset. We have to arrange the columns to generate the heat map. Let's use the pivot method to arrange the columns: month, year, and passengers. Let's view the flight dataset that's now ready to generate the heat map. Let's use the heat map method and pass flight data as an argument. This will generate the heat map, which you can see here. In this demo, you learned how to create and display a heat map. Pie charts. Pie charts are typically used to show percentage or proportional data. Note that usually the percentage represented by each category is provided next to the corresponding slice of the pie. Matplot library provides the pie method to make pie charts. It has several advantages. It summarizes a large data set in visual form. It displays the relative proportions of multiple classes of data. The size of the circle is made proportional to the total quantity. In this demonstration, you'll learn how to create a pie chart and display it. First, import matplotlib pyplot. Type %matplotlib inline to view the plot in Jupyter Notebook. Type the job data within parentheses using single quotes separated by commas. Specify the labels as IT, Finance, Marketing, Admin, HR, and Operations. Specify the slice IT to explode. Use the show method to display the pie chart. You can see the pie chart with the slices, labels, and IT, the largest slice. Error bars. An error bar is used to show the graphical representation of the variability of data. It's used mainly to point out errors. It builds confidence about the data analysis by unleashing the statistical differences between the two groups of data. It has several advantages. It shows the variability in data and indicates the errors. It depicts the precision in the data analysis. It demonstrates how well a function and a model are used in the data analysis. It defines the underlying data. Seaborn is a Python visualization library based on Matplot library. It provides a high-level interface for drawing attractive statistical graphics. It was originally developed at Stanford University and is widely used for plotting and visualizing data. There are several advantages. It possesses built-in themes for better visualizations. It has tools built-in statistical functions which reveal hidden patterns in the data set. It has functions to visualize matrices of data, which become very important when visualizing large data sets.
Hey, want to become an expert in big data? Then subscribe to the Simply Learn channel and click here to watch more such videos. To nerd up and get certified in big data, click here.
Okay, so again, actually we have a lot of discussions pa to cover, no? Because giving an example codes must be important in our field in IT, especially in IT, no? And we don't have enough time, no? So we may continue next meeting right after the or before maybe for the presentation of chapter or module number 4. Okay, so again, I just want to reiterate that we need to follow some step-by-step guide to get started in data visualization, because data visualization is a critical aspect of big data analytics that enable us to represent data graphically and communicate insights effectively. So it involves creating visual presentation of data information as what our video presentation, no, graphs, charts, maps that help us understand complex data and identify patterns and trends. So I think that's it for today.